In this video, we'll be looking at how to write an equation to model real-world linear situations and then use these equations to make predictions. Essentially, what we are learning about here are linear word problems. So word problems, real-world situations, that can be modeled by a line graph. So let's start by reading through this first example and underlining what we find important. So here this says that the math department sponsors a math family fun night each year. In the first year, there were 35 participants. So that it looks like information to me that is linked. In the third year, there were 57 participants. So again, pieces of linked information. So what I'm noting here is that because both of these pieces of information are linked, that they have to be points. So I'm going to have a point here in red, and then I'm going to have a point here in blue. Now, the first piece I need to determine is which becomes my x-coordinate and which becomes my y-coordinate. And remember, we're always looking for, okay, is there time? And if there's time, that's the x variable. And is there cost? Because if there is a cost, that's our y variable. And what we notice here is that we have year. And year is a type of time. So those years are going to go in for our x variable. So my first point is going to be the first year, so year 1. And there were 35 participants, or people. And then in the second point, I have the same pattern. We have year 3, so I have after 3 years, there were 57 participants. So here, as I make these points, what I'm doing is I'm assigning my x variable to be the time. So x is the year number, and y is my number of people participating, or my number of participants. So now from here, I need to utilize this information to write the equation of a line into slope-intercept form. Now to do that, I need to start by finding my slope, and I'm going to use my 2 points to help me find my slope. So I have x1, y1, x2, y2. So I'm going to take 57 minus 35 over 3 minus 1. 57 minus 35 is 22. 3 minus 1 is 2. And so my slope becomes 11 over 1, or 11. Now I'm going to take this information, and I always start in point slope form. So we're going to put it into point slope form, which is y minus, I need to pick a point, so I'm going to pick this first point here. So y minus my y-coordinate of 35 is equal to my slope times x minus my x-coordinate of 1. So that there is point slope form, and I then need to rewrite it into slope-intercept form. So I start by distributing. I have y minus 35 is equal to 11x minus 11. I then add 35 to each side. So we have y is equal to 11x plus 24. There is my slope-intercept form equation of this situation. All right, example 2. Mrs. Conway's swim team has hired a personal trainer to run the dryland program for her swim team. The trainer charges $50 for the first 3 hours, and then $20 per hour after that. So remember that word per is telling me slope. So here I know that I have a slope value, so I can say my m value is essentially $20 per 1 hour, or 20. And then I can also see that I have a point, and I need to decide how I want that point to be written. Remember, x is typically our time, and y is typically our cost if they are present. So in this point here, $50 for 3 hours, My time is the 3 hours, so I'm going to put 3 hours. And my cost is $50. Now the next part here says, what do X and Y represent in the context of the problem? Well, I'm going to look right at my points here. X is essentially the number of hours of dry land that the swimmers have. And Y is my total cost. So now from here, I'm going to utilize this information to write the equation into slope-intercept form. So here I can see that I already have a slope and I have 1 point. Now remember, we always start in point-slope form. So I'm going to start with y minus my y coordinate of 50 is equal to my slope of 20 times x minus my x coordinate of 3. So remember, this is our point-slope form. This is where we always start. Then from here, we're going to rewrite this into slope-intercept form. So I start by distributing to get rid of the parentheses. So I have y minus 50 is equal to 20x plus a negative 60. Then from here, I add 50 to each side. So I end up with y is equal to 20x plus a negative 10, or you can have y equals 20x minus 10. Those are both the same statement, so either is fine. Okay, so here in example 3, it says a cable company charges $44 for basic service. Each premium channel then costs an additional $16 per channel. So if I start by determining what I currently have in this problem, the word per tells me slope, so I know my slope is 16 over 1, or 16. And then from here, well, it doesn't seem like I have a point. This really represents a point. This is really saying that when we have 0 premium channels, our cost is $44. So they've actually given us a slope with the 16 and a point with 0 premium channels costing $44. Remember, cost always goes in our y coordinate spot. Then from here, we're going to write the equation of our line, and we're going to ultimately end in slope-intercept form. So we always start in point-slope form, so we do y minus our y coordinate of 44 is equal to our slope of 16 times x minus our x coordinate of 0. So then I'm going to rewrite this equation into slope-intercept form. So I distribute y minus 44 is equal to, we have 16x minus 0. We then add 44 to each side, and in slope-intercept form we end up with y equals 16x plus 44. And our final word problem here, this one says, in the supermarket, each cup costs $4 and each bowl costs $6. If you want to spend exactly $36, write an equation in standard form to model the situation. So I know this is going to be in standard form because this is a cost calculating equation. So write an equation in standard form to represent the situation. Well, you need to think about how cost is calculated. And I know cost is calculated by taking the number of cups I sell and multiplying it by 4. So let's say that x is equal to the number of cups. So in order to calculate my cost of my cups, I would take 4 times x, because it's $4 per cup, and x is my number of cups. Then I'm going to add that together with the bowls. So I have y is equal to my number of bowls. So I would have $6 per bowl times the number of bowls. And those two costs added together need to equal a total of $36. So there's our equation written in standard form. Again, just to reiterate, we have $4 times the number of cups we buy plus $6 times the number of bowls we buy, and that equals a total of $36.